topics at a glance. So electricity, in the electricity chapter we have topics called charge, coulomb, then we come to current, then time, potential difference, work done, then Ohm's law, then resistance, okay, resistance, then
Yeah.
circuit, and we'll study about series connection and parallel connection, and then we'll study about conductors and insulators, then we'll study about measuring instruments, then we'll study about voltmeter, ammeter, then we'll study about resistivity and a relation between resistivity and resistance, and the heating effect of electric current and applications of that, so where we are using the electricity to produce heat, and finally we'll study about power. Okay, so these are the
Yeah.
topics we are going to study, and that will be the end of this chapter. Okay, very important
Okay.
chapter. Yeah, for those who want to pursue engineering, career in engineering, particularly electrical engineering, mechanical engineering, any branch of engineering, if you want to pursue, this will help you a lot. Okay, right.
Okay.
Right. Okay. Okay then. So we'll start with the basic terminology called charge, and before that, let me start with an example. Yeah. Now, in our daily life, we are seeing so many objects or so many things which are dependent on current. For example, when we want to charge a laptop or when we want to charge a mobile, definitely there will be flow of current. So ultimately, there will be current supply. So nowadays, even electronic vehicles are depending upon the current. So what does this current means? What does this current mean? Like, see, we cannot see current. Current is not visible to us. But
Yeah.
what actually current means? What is causing the electronic vehicle, a vehicle to move with the help of current? So because anyway current is not going to convert into petrol or any kind of fuel, but that is causing some movement
Yeah.
to the vehicle, that is causing some movement to vehicle. And what does this mean, and how an electric current will can be able to charge a mobile phone? Here, when we are using a term called charging of a mobile, charging of a laptop, charging of any gadget, so that is very
Yeah.
important term, that is very important term. Charging itself will give the definition of current. So current is nothing but flow of charge. Okay, current is nothing but flow of charge. And what is meant by charge? In universe, every body, if you see it, every body is composed, or every body is made up of lot of atoms, right? Lot of atoms. And
Yeah.
each atom will contains protons, electrons and neutrons. Protons, electrons and neutrons. And here we are particularly discussing about electrons, which are responsible for flow of current. So the main thing or the main term which are responsible for flow of current is nothing but electrons. Electrons are the thing which are causing the charge to flow and thereby producing current electricity. So electrons electrons in a body electrons in a body or electrons in an object are responsible responsible for flow of current. Electrons in an object are responsible for flow of charge or for current. Directly we can say it as current. So electrons, if a body contains electrons, then that can produce current, and that can allow the current, because the movement of electrons will help the current to pass through it. The movement of electrons will help the current to pass through it. Okay, now I think you can understand this concept. Okay, now if I can ask you a
Yeah.
simple example, I'll give you two names of two objects. Okay, one is plastic and one is steel, iron. Okay,
Yeah.
one is plastic. I can say the example of plastic, or maybe anything. You can say, take it as some carbon. Okay, carbon, or plastic is usually made up of this carbons. Okay, yeah,
Yeah.
yeah. So current is easily passed in carbon, or it can be easily passed in a steel body.
steel body.
Yeah, because the thing is, steel bodies are made up of iron or other metals, and metals have free electrons. Can you tell me any examples of metals?
Uh, um, Sodium.
Very good. Sodium. And atomic number of sodium is
Um, 11.
very good, 11. So if you can write electronic configuration of sodium, it will be 1s2, 2s2, 2p6, and 3s1. That means there is one free electron. There is one free electron in the outermost shell of sodium, and this free electron will try to combine, or you will try to combine, will be looking upon to some other element to form a bond. Okay, to form a bond,
Yeah.
and this free electron is always moving. See, uh,
Okay.
in a class, if there are any pairs, like for example, if I want to make a skit or if I want to make a project, so I have 11 members and I asked each student to make up a pair. So there will be 5 pairs and there will be one boy left, and he will be moving all around to find a pair. There will be movement.
Yeah.
In the same way, here the free electron in the outermost shell will be moving continuously to find a pair, and this movement of electrons are responsible for causing current. So it is therefore all the metals will have this free electrons. If you take iron also, so the atomic number of iron is 26. Okay, so even it will have some free electrons like that. Sodium, um, aluminium, and steel, like that, every metal will have free electrons, and these free electrons are responsible for flow of current, and the bodies which are allowing the current to pass through them are known as conductors. That's very important. Okay, conductors. The bodies which allows the current to pass through them. The bodies which allows the current to pass through them are known as conductors, and the bodies which are not allowing the current to pass through them are known as insulators. Insulators. Wood, rubber, plastic, all this will come under insulators. Wood, paper, rubber, plastic. Okay, so the bodies which does not allow the current to pass through them
Yeah.
are known as insulators. So it is therefore uh, declared as the bodies which are allowing current to pass through them are known as conductors, and conductors only will pass the current or will uh, generate the current. Okay, now the reason why conductors can allow the current pass through them is they are nothing but metals, and all the metals will have free electrons, and movement of free electrons causes current. Okay, now,
Okay.
so here we are discussing about a term called charge. Okay, term called charge, and charge is nothing but amount of electrons present in a body. Charge is nothing but the amount of, or the number of electrons, the number of electrons present in a body. The number of electrons present in a body is known as charge. Okay, electrons are responsible for causing current. If there are more electrons, more current will be passed. If there are less electrons, less current will be passed. Remember this point. Electrons are alone responsible for allowing or for passing the current. So if there are more electrons, if there are more free electrons, more current will be produced. If there are less free electrons, less current will be produced. And this electrons, number of electrons combinedly, it is called by a term called charge. Okay, charge is given by the number of electrons present in a body. Charge is nothing but the number of electrons present in a body. So charge is denoted by the symbol capital Q. Okay, so charge is given by n times E, n times E, where n is the number of electrons and E is the value of one electron. Okay, so for example, if a body is like this, okay, if it is having only one free electron, then the charge present in this body is Q is equal to 1 electron. And if a body is there, if it is having 2 electrons, so it will be having charge of 2e. And if a body is there, there are lot of electrons, like lot and lot, that means n electrons, then the charge is given by Q is equal to ne. Okay, now, here comes the important thing. How will you measure the electron? So, the thing is here, for example, if we are having like 1 gallon of water or 1 liter of water, so it can be written as some 1 by 1000 meter cube. Like that, and the unit for measuring the amount of electrons is coulombs. So one electron causes 1.6 into 10 power minus 19 coulombs. Coulomb is nothing but the amount of charge present in a single electron. The amount of charge present in a single electron is equal to 1.6 into 10 power minus 19 coulombs. So this is the numerical value, how much an electron can produce a current. If one electron is there, it will produce a current equivalent to 1.6 into 10 power minus 19 coulombs. So it is very small. In the same way, if there are 2 electrons, it can cause a amount electric current of charge 1.6 into 10 power minus 19 into 2, like that. Okay, now this is very important. One electron has 1.6 into 10 power minus 19 coulombs. Okay,
Yeah.
and so discussing again charge. So charge is defined as the number of electrons in a body. Okay, if there is one electron, the charge present in a body is 1e. If there are 2 electrons, the charge present in a body is equal to 2 times e. If there are n electrons, the charge present in a body will be n times e. Okay, right, right. So this is all about charge and coulombs. Okay, right. Now we'll discuss about current. Current is defined as flow of charge. Okay, so for example, if charge is there inside the body, that is not current. The amount of charge flowing in a given time, the amount of charge flowing in a given time is known as current. For example, like let me give an example with electric mobile. So assuming this as our mobile, so this will be a charger. Now, for example, if the phone is drained up because of less battery, okay, there is only 20% battery. So now if you connect the charger, the electrons, that means electrons will flow from this plug point to this mobile like this. Okay,
Yeah.
and this movement of electrons is known as current. So current is defined as the amount of charge flowing per unit second or flowing per unit time. The amount of charge flowing per unit time per unit time or second
Yeah.
is known as current. Current is denoted by the symbol I. Current is denoted by the symbol I, and mathematical formula for current is I is equal to Q by T. Current is equal to Q by T. Okay, so current is defined as the amount of charge flowing per unit time. Amount of charge flowing per unit time.
Yes.
Okay, so I is equal to Q by T. The amount of charge flowing per unit time is known as current. Now here I'll arise a new word called rate. For example, any quantity any quantity, if if it is changing with respect to time, remember this point, any quantity, if it is changing with respect to time, then we can use a word called rate of change. Any quantity, if it is changing with respect to time, for example, the distance covered by a bus from one time to another time, that means the bus is moving, the initial position of bus is at some A at time t1, and the final position of bus will be at B at time t2. That means that position of bus is changing from one point to another point with respect to change in time. If any quantity changes with respect to time, it may be distance, or it may be displacement, it may be velocity, whatever it may be, it may be current, or it may be charge, whatever it may be, we can use a term called rate of change. Okay, so since current formula is giving, it will be given by Q by T, that means the amount of charge in a given time. The amount of charge in a given time, whenever we are dividing any quantity by time, we can use a term called rate of change. Okay, so therefore current can also be defined as rate of change of charge. Rate of change of charge. Okay,
Yeah.
rate of change means dividing with respect to time. Rate of change means dividing with respect to time. That means with the change in time, how much it is changing. So rate of change means dividing with respect to time. Dividing with respect to time. So I is equal to Q by T. I is equal to Q by T. Okay. Now, since I is equal to Q by T, we already know that Q is total amount of charge present in a body, right? Q is total
Yeah.
amount of charge present in the body, so that is given by Ne. So we can also give this formula for current. So I is equal to Q by T, where Q is known as Ne by T. Now, current is measured in amperes. The unit of current is amperes.
Yeah.
Unit of current is amperes. So it is a name of a scientist. Okay, so it is measured in unit called ampere, and the device used for measuring current is ammeter. Okay, so uh, up to here we have discussed two topics called, one is charge and one is current. So charge is nothing but the number of electrons present in a body, and that electrons are responsible for causing current. And electric current is defined as amount of charge flowing in a given time. We cannot say the current flowing all the day or all the hours or all the years. In a given time, in a given time, so charge flown per given time is known as current. Now from here onwards, I'll relate the flow of current with the flow of water. I'll just relate the flow of current with the flow of water. So I'll just compare these two so that you can understand better. Okay, now if there is one pipe, if there is one pipe and there is some water, a little bit of water is there. Okay, or I can take any example like, if two buckets are there, if two buckets are there and a pipe is connected between one bucket to another bucket, if two buckets are there, a pipe is connected between one bucket to another bucket. Now will the water flow from one bucket to another bucket on its own? If two buckets are there and there is water in the two buckets, and if we connect a pipe between a joint pipe joint between one bucket to another bucket, will the water flow on its own from point 1 to point 2? No. So to cause the flow of water, what should we do?
We should get a pipe to connect them.
Okay, so let me draw the diagram, you can understand very clearly. Yeah. Now, can you tell me in which case out of the two cases will the water flow? Will there be flow of water?
Case 2.
Exactly, case 2. Because to promote or to cause the flow of water, there should be level difference. So, yeah, one bucket should be on higher level and one bucket should be on lower level. Then the water will be flown because of
Oh, because of gravity.
exactly correct. So because of gravity, water will flow its on own. Because if we are providing level difference, water will be flowing from upward point to downward point. Usually water is flown from higher energy point to lower energy point. So water flows from higher energy point to lower energy point. And here in second case, this point is at higher level, whereas this point is at lower level. Point A is at higher level, point B is lower level. So this will cause a head difference, level difference. Potential difference will be there because of the position, and this difference will cause the flow of water. Usually it is known as gravity. Okay, now in the same way, if we want to cause the flow of charge, what should be the thing which promotes the flow of charge? In the same way, just like, yeah, exactly correct. So if you want to cause the flow of charge, if you want to make the charge to flow from one body to another body, there should be a difference called potential difference, okay, or voltage difference. For example, as I told you here, yeah. So here, assuming the phone is at, I mean, the battery, the plug point, if we can observe clearly, it will be given as some 66 volts, and the phone is of some like 30 volts or some 20 volts, like that. If you can see the battery of the phone, it will be given like that, and this difference will cause the flow of charge. So if the charge has to be flown from one point to another point, there should be voltage difference, and that voltage difference is also known as potential difference. Okay, so if charge, in bracket I write as electrons, if charge or electrons has to be flown from one point to another, there should be voltage difference, which is known as potential difference.
Yes.
Okay, so if there has to be a flow of charge, there has to be potential difference, and this potential difference can be defined as the amount of work done to bring a unit charge from one point to another point. Here we are telling that, here you are telling that if there is difference in voltage, and that will cause the movement of electrons, that will cause the movement of charge. And particularly if we want to define it clearly, what is defined by potential difference? The potential difference is defined as amount of work done in bringing an electron from one point to another point. So for example, this electron is flowing like this. If you can see the diagram here, just for a second,
Yeah.
let it be point A and let it be point B. So here electron is flowing from this point A to point B. The same electron is flowing from point A to point B, and the amount of work done in bringing this unit electron or unit charge from one point to another point is known as potential difference. Okay, if we know the
Okay.
if we know the volts, like for example it is of 20 volts or 30 volts, definitely this difference will cause a flow of charge. But here, if you want to define very carefully, the difference has to be defined for one electron. So the potential difference is defined as, I'll write the definition. Okay, so the amount of work done, the amount of work done in bringing, the amount of work done in bringing a unit charge from one point to another point, from one point to another point,
Yeah.
is known as potential difference, is known as potential difference.
Yeah.
Okay, so the amount of work done in bringing unit charge from one point to other point, how much work we are doing to bring an electron from one point to another point, because only if we can able to create difference, then electrons will pass, and the electron passing of electrons will cause current. So that difference we have to create,
Okay.
and that difference for one electron is known as potential difference. Okay, now from the definition we
Yeah.
can, from the definition, yeah, from the definition we can give a mathematical formula for potential difference. So I'm saying that the amount of work done, the amount of work done, okay, amount of work done in bringing a unit charge is known as
Yeah.
potential difference. So potential difference is denoted by symbol V. So V is equal to W by Q. So it can also be defined as, from the diagram, potential difference between 2 points VA minus VB is equal to W by Q.
Yeah.
Okay, so usually we'll denote by single letter V. V is known as potential difference, or if you want to clear it, make it very clearly, you can write it as VA minus VB is equal to W by Q. The amount of work done, the amount of work done in bringing a unit charge from one point to other point is known as potential difference. Okay,
Yeah.
that's it. Now, so for every definition we are studying, we have to study a mathematical formula, we have to know the unit it is measured, and we have to know the device with which it is measured. So like for charge, the unit is coulombs. Like for charge, the unit
Yeah.
is coulomb. Like for current, the unit is
Okay.
amperes. For current, the unit is amperes. And for current, the measuring device is ammeter. In the same way, the unit of potential difference, the unit of potential difference is volts. VOLTS, volts. And it is measured by voltmeter. And it is measured by voltmeter. Okay, I'll just prepare a small table here. So I'll write terms here: charge, current, potential difference, or voltage. So I'll write measuring unit and measuring device. For charge, the measuring unit is coulombs, and there is no particular device to measure charge. Even we have nothing, I mean, no particular device we can directly measure, because charge, the measurement of charge with respect to time is known as current. Okay, so for current, the unit is amperes, and the device is ammeter. And potential difference, the unit is volts, and the device is voltmeter.
Okay.
Okay, so for every term, for every definition we are defining, so we have to know the unit it is measured, and we have to know the device with which it is measured. Okay.
Which device measures the charge of an object, or is there no device?
Yeah, let me check it now, because there is no particular device for charge. We can even measure it in using ammeter also. Yeah, let me see it. Yeah, charge is measured by electrometer. Electrometer.
Okay.
But here we don't make, because in this chapter we cannot directly find charge. In fact, we'll find directly current. So it is of no significance. So better remember the name. That's it. Okay.
Yeah.
In all the instruments, in all the practical experiments we are doing, we'll directly use ammeter and voltmeter, which will gives us its amount of charge also. But only if you want to measure only charge, we can use electrometer. Okay.
Okay.
Right.
Yeah.
Yeah. Okay. Right. Now, without current supply also, there are a lot of devices which are producing current and which are making the vehicles or objects to move, and with that devices are known as batteries, right? So batteries are quite commonly used in a lot of instruments which are causing current. And as we know that, let me draw the diagram. Let it be positive terminal, let it be negative terminal. So the quite commonly used batteries are Duracell, Nippo, Everready, like that. Okay, so there will be some information like this: 1.5 volts. Now, if a battery has to produce current, there should be some flow of electrons. And if there should be flow of electrons, there should be potential difference. And that potential difference here in battery is caused by the chemical inside the battery. The chemical inside the battery will cause the potential difference. Okay, so between this positive terminal and negative terminal, so there will be movement of electrons, and that movement of electrons is promoted by the chemical inside the battery.
Okay.
It may be lithium, or nowadays we are using lithium batteries, it may be zinc. Okay, so like that.
Yeah.
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 So now we will discuss about a term called Ohm's law, which is very important. Okay, which is very important. Ohm's law.
Okay.
Okay, so now, rather than directly saying you the definition of Ohm's law or statement of Ohm's law, I'll make you to create a definition so that it will be very useful for you and you can remember it for lifetime. So let me draw the diagram first. So that you can itself will create the definition. Okay. Yeah. Now, can you tell me where will be the more flow of water in which case? Is it case 1, or is it case 2, or is it case 3?
Case 3.
Yeah. So in case 3 there will be more flow of water because of more level difference. Okay,
Yeah.
yeah, as I told you, water will always flow from higher energy point to lower energy point. In each case it flows in this negative downward direction. And particularly when you look at the points B and A, point A is at higher level and point B is at lower level. So that difference will cause a difference in potential energy. So because there will be more difference, there will be more difference in potential energy. So in case 3 more water will flow. That means here the flow is directly proportional to level difference. So flow of water is directly proportional to level difference. Okay, in the same way assume the water as here electrons are charged. So if more current has to be passed, what should be more?
There should be more flow of charge.
That means there should be more potential difference. If potential difference
Oh,
is
yeah.
more, yeah, if potential difference is more, current will be more. Okay, see here, if potential difference or voltage difference is more, current will be more. If potential difference will be more, current will be more. That means the current through a element or current through an object is directly proportional to potential difference applied between its ends. Okay, so let me write the clear definition of Ohm's law. So Ohm's law states that the current through a metallic element or any object, the current through a metallic element is proportional to is proportional to potential difference between its ends between its ends. Okay,
So
so
then it will have to be current is equal to, or potential difference is equal to K into current. So what would that
exactly,
K be, that constant?
yeah, that constant is known as resistance. Okay, so
Okay.
now I'll derive that equation. Okay, so current is directly proportional to potential difference, and here there is one condition. Okay, provided there should be same constant temperature. Temperature should not change in between. Okay, so at constant temperature we have to add the term. Okay, so the current through a metallic element is proportional to potential difference. That means I is proportional to V. So if we want to remove this proportionality constant, we have to add proportionality constant. We have to keep proportionality constant. If you want to remove its symbol, we have to add a proportionality constant, that is K. In this case, that K, proportionality constant K, is known as R. So let me write it. Okay. So I proportional to V, we can even write as V proportional to I, and V is equal to IR. V is equal to IR. So this is very important formula. Ohm's law usually means V is equal to IR. Ohm's law usually means V is equal to IR, where this R is known as proportionality constant. R is known as
Okay.
proportionality constant. Okay,
Yeah.
so we can even write it as I is equal to V by R, or I is equal to 1 by R into V.
Yeah.
Okay, so you have to remember this formula. V is equal to I into R. So
Into
potential
R. So
difference is
potential.
given by I into R.
Okay.
Yeah,
Yeah.
Yes, we have discussed that R is a proportionality constant. In real life also, resistance is constant for a given element. For example, if you are taking any metallic element, be it be a copper wire, usually we'll take copper wire to conduct all kinds of experiments. We can even take silver wire, we can even take gold wire. All these are metals, and all this can pass current through it. But the cheapest material available to us, cheapest conductor available to us is copper wire. We cannot do all experiments with silver wire, because silver is more conductive, and it is very dangerous to do such kind of experiments with silver. And even if it's even it is costly than copper. So if we can take copper wire, so if there is more potential difference, more current will be passed, and the resistance of copper wire will not change. So that's why it is constant. That's why it is constant. The resistance of copper wire will depends upon the wire. So for entire length of wire, for any copper wire, the resistance will not change, and that's why it is known as constant. Okay.
Okay. Yeah.
Now we can define resistance in another way. So since V is equal to IR, or we can write as I is equal to V by R, I is equal to V by R. So R is known as resistance, and by the word itself, resistance means opposition. Resistance means opposing.
Yeah.
Yeah. So
Yeah.
the opposing force. You cannot exactly use a word called force. So, but we can like use any kind of that thing. Okay, the opposing force or the opposition force which resists the current, or I can give you very clear definition. Just wait for a second. The quality of a wire or the quality of a material. Yeah, the quality of a material to oppose the flow of current, to oppose the flow of current. The quality of material to oppose the flow of current is known as resistance, is known as resistance. So
What actually causes this resistance?
exactly, I'll tell you. See, while we are moving in any highways or any roads, so sometimes we will be seeing this kind of speed bumps.
Yeah.
So what is the purpose of placing speed bumps, speed breakers?
To slow down the car.
Yeah. So it is not completely making the car or bike to completely to come to rest, but rather to reduce speed. Okay.
Yeah.
Now, in the same way, the symbol of a resistance is very much related to current. I mean, speed breaker. Okay. The symbol of resistance is given as like this. So this is the resistance symbol.
Okay.
Okay. Now, if any current is flowing, so for example, uh, yeah, for example, there are 2 points from A to B. Okay, there are 2 points from A to B, and if there is no if there is no restriction, like current will exactly flow, the amount of electrons, the flow of charge will be same from point A to point B. They'll flow in a very less time. They'll flow in a very less time from point A to point B. But if we connect the resistor like this, the current will though the magnitude of current will not change, but it will take more time. The pace of current will be reduced. The pace or the speed of current will be reduced, because
Okay.
Now it has to flow all through this line. It has to go up and down, up and down, up and down, up and down, then it has to go like this. But if it is a straight line path, it will go very fast, just like the purpose which we are using for speed breakers. Okay, so in the same way the symbol is also same, though the main purpose of resistance is to decrease the pace of current, to decrease the speed of current, not to decrease the value of current, but to decrease the pace of current.
Okay.
Okay, so remember, it will cost more time to reach from one point to another point. Okay, so resistance
Okay.
will, what you call, will reduce the space of current, so that if we can apply, if we can connect any object, all of a sudden a bulb, for example, if the battery, if you can use this 9 volts battery, if you can connect a small bulb directly to the battery, positive terminal, negative terminal, it will just blown away. It will be like, what you call, it will be, I can say it as, it will fire and it will get damaged. Okay,
Okay.
because whenever we are using small bulbs, the capacity of that bulb is to take only some 1 volt or 2 volt. The capacity of the bulb is to
Okay.
take 1 volt or 2 volt. But if we are connecting that small LED bulb to a 9 volt battery, so the potential difference is more for a 9 volt battery, and more current will be passed. As I told you,
Okay.
if there is, if there are two batteries, okay, one is small battery 1.5 volts and one is other battery 9 volts, and we have a small LED bulb which can hold only some 1 volt or 2 volt. Now if we can connect that LED bulb, let me draw the diagram here. Okay, okay, now in first case the bulb will glow, and it will glow continuously because there is power supply, there is what you call limit on the power supply. But in the second case, since the bulb only can handle 1 volt or 1.5 volt, here we are connecting it to 9 volt battery. If there is more potential difference, current will be more. If there is more current, so directly more current will pass through the bulb, and bulb will glow and get damaged suddenly. Okay, bulb ఏమవుతుందంటే
Okay.
కాలిపోతుంది అనమాట. It will just fire it off, అంటే just like we are seeing, it will catch what to call damage. All of a sudden it will get damaged. Okay,
Yeah.
so in that case we have to use resistance. Like this, whenever connecting, we have to use resistance in between one terminal. Okay, so and that resistance will reduce the speed of current, and it will reduce the pace of current. Okay, clear?
Yeah.
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 And this resistance is not same for all kind of material. It will be different for silver, it will be different for copper, it will be different for aluminum, it will be different for gold, it will be different for steel, like that. So this resistance depends upon type of material, and also length of material, and also area of cross section of wire. Okay, so I'll discuss the thing. So resistance depends on number one, type of material. Resistance depends on type of material. Number two, it also depends upon length of wire. And number three, it also depends upon area of cross section of wire. So resistance depends on type of material, length of wire, and area of cross section of wire. So it is somewhere related between, we can have a relation between all these three factors, and it is given by R is equal to rho into L by A. R is equal to rho into L by A, where R is known as resistance. R is known as resistance. Rho is known as resistivity. L is known as length of wire. L is known as length of wire, and A is known as area of cross section of wire. Area of cross section of wire. Okay, now, so from here onwards we will be discussing more about this resistance. We have lot of resistors connected in series and resistors connected in parallel. Okay, now before going to series connection and parallel connection, let me clear the unit of this resistivity. The unit of this resistivity. Now from this equation, can you write equation for resistivity? Can you write equation for resistivity? Yeah. Okay. Now, since in the previous topic we have discussed about resistance, okay, the unit of, there we forgot that thing. The unit of resistance is ohms. The unit of resistance unit is ohms, and it is denoted by the symbol ohms.
Yeah.
It is given by the scientist name. Okay, ohms law, ohms law, ohms law. The same scientist, we are using the unit it as the same by the same name. The unit of resistance is ohms. Okay, now we will try to find the unit of this resistivity. I hope you got the same formula for resistivity. Rho is equal to R into A by L, right?
Yeah.
Yeah. Now what is unit for resistance?
Will it be
Ohm. No, for resistance.
Yeah. Oh yeah.
For
resistance, yeah, it will be ohm.
What is unit of area? Area of cross section.
Area will be meter squared.
Very good. Yeah.
Squared.
Let me take it as some meter square. Okay. And what will be unit of length?
Length will be meters.
So meter, yeah, meter square. So meter square by length is meters. Okay. Now meter square by meter, we can cancel this meter with one of square, right?
Yeah.
So then it will be ohm meter, and that is a unit of resistivity. Ohm meter, ohm meter. Okay, so I write it clearly. The unit of resistance, the unit of resistance denoted by symbol R is ohms, whereas the unit of resistivity, the unit of resistivity denoted by symbol rho, ROW, rho, okay, rho, is given by ohm meter, ohm meter, ohm meter.
Yeah.
Okay, okay. Now here you have to know two terms called resistivity and conductivity. Resistivity and conductivity. Okay, there is very simple definition. You can even what you call by the name itself you can even guess the definition. Conductivity means it is different for different metals. The ease with which a material allows the current to pass through it is known as conductivity. The ease, that means how much ease it is allowing the current to pass through it, is known as conductivity. The ease with which a material allows the current, the material allows the current to pass through it is known as conductivity. And quite opposite to it is known as resistivity. Resistivity is defined as the strong. How much strong? Okay, how much strong? We can use the or something. I mean, I don't bother about grammar. Okay, the strong, the hard, or what to call the hard, with which a material oppose the flow of current. Oppose, oppose the flow of current is known as resistivity. The ease with which a material allows the current to pass through it is known as conductivity. Okay, highest conductivity is for silver. It will easily allow current to pass through it. Then copper. Okay, like that. And conductivity is very less for plastic, very less for glass, very less for rubber, very less for paper, very less for wood. Conductivity. Conductivity is highest or more for conductors like silver, copper, or steel, aluminum, like that, gold. Whereas it is very less for insulators like wood, paper, rubber, plastic.
Yeah.
Conductivity means the ease with which a material allows the current to pass through it is known as conductivity, whereas resistivity means how much strong a material is opposing the flow of current. How much strong a material
Yeah.
is opposing the flow of current is known as resistivity. Conductivity is accepting current, resistivity is opposing current. Conductivity is accepting current, resistivity is opposing current. Okay,
Yeah.
yeah. So now we have this topic called resistors connected in series and resistors connected in parallel. So it is a very big topic. So it will be more of problems. I think if we are good in this all these previous topics what we have today, then we can go through that topic some other day. Or if you want me to continue, we can.
Yeah. It's your choice. I'm okay with anything.
Okay. So is there any free time for you the other day, tomorrow, like that?
I think I'll be free next weekend again.
Okay, then I'll do one thing. Okay, I'll just record a video. I'll just record a video of a series connection, parallel connection. Then I'll send it to you. Okay.
Oh, okay.
Okay, by next week you finish that topic, and I'll give some homework to you. By you can within this week you can do the problems, so that I can understand how much where you are. Okay, so okay, then I'll share all these notes with you now, and I'll share even that the recording of this session. Okay. Yeah, thank you, Rishi. You can ask me if you have any doubts in WhatsApp also.
No, I'm fine.
Yeah, okay. I'll share the material which I'm following. In India, we'll be following the most famous material known as HC Verma. HC Verma here, the people who are studying for IITs and NITs, so they'll follow HC Verma material for physics. I'll share the soft copy of the HC Verma material, and I'll share the notes of what we have discussed today and recording of this today's session. Okay.
Okay.
Okay, Rishik. Thank you. Have a nice day.